So today we are going to discuss all the terminologies related to fisheries. This is very important for your examination. Something or the other can be asked from here, and it also helps you build up your fundamentals. So the first one is exclusive economic zone. So every coastal nation has the right to explore and use marine resources up to 200 nautical miles from its shore. This zone is called the exclusive economic zone or EEZ. For example, India's uh, exclusive economic zone extends into the Arabian Sea and Bay of Bengal, where our marine fishing activities are mainly going to occur. Okay. Then we have pelagic fisheries. These are surface or mid-water fisheries targeting fish like sardines and mackerel that swim in open water rather than near the seabed. Then we have demersal fisheries. In contrast, demersal fisheries focus on bottom dwelling species like prawns, catfish, and groupers caught using bottom trawls or traps. Then we have the term overfishing. I know you are aware about it, but let's still discuss it. This happens when fish are caught faster than they can reproduce, leading to resource depletion and imbalance in marine ecosystem. Okay, so harvesting fish beyond natural regeneration. So you are using it more than it is available. Then it is CPUE, catch per unit effort. So it indicates the health of fish stocks. If fishermen catch less despite the same effort, it signals overexploitation. Then we have maximum sustainable yield, MSY, largest catch that maintains population levels, basically the safe limit for fishing. So it is the largest quantity of fish that can be harvested without reducing future population levels. Okay. Then we have fishing effort. It refers to the amount of activity like the number of boats, gears, or fishing hours used to catch fish. Okay. Basically, this is the effort you are putting in. So, close season. A ban period imposed during fish breeding or spawning seasons to protect stock regeneration. For example, India declares a monsoon ban along coast every year. Then we have mesh size regulation. By controlling the net mesh size, small juvenile fish can escape, ensuring only mature fish are harvested. Okay, so this will prevent the juvenile catch. Then we have bycatch. These are non-target species unintentionally caught during fishing, like turtles or small fish in trawl nets. Basically, we don't want to catch them, but they somehow get caught up in the net. Okay, then we have ghost fishing. Even lost or abandoned nets continue to trap marine life, a major threat to ocean ecosystems. Right, this is a problem. Then we have trawling, a fishing method where a large net is dragged through the water or along the sea bottom to catch fish like shrimps or demersal species. Right now, we had discussed that they are bottom dwelling, so trawling will help us to get them because they'll go to the deeper part of the sea. Okay. Okay, then we have gill net, a net that traps fish by their gills, efficient for catching species like hilsa and katla. Then we have purse seine, the massive net that encircles fish schools, often pelagic species like tuna, and then closes like a purse at the bottom. Okay, so this is a method of catching. Then we have quota system. Governments allocate fishing limits to prevent overexploitation, ensuring sustainable fish harvest. Right, so they put a capping on it. Let's go to of aquaculture. Okay, so the science of fish farming under control condition is basically principles of aquaculture. First is monoculture, raising a single fish species in one culture unit, like cultivating katla alone in a pond. Okay. Next we have polyculture, farming multiple compatible species together to utilize all pond zones. For instance, katla, rohu, and mrigal in one pond. Okay. Then we have composite fish culture, a refined version of polyculture combining Indian major carps, katla, rohu, mrigal, with exotic carps like silver and grass carp, maximizing productivity. So basically, this is a more refined version of polyculture. Then we have integrated fish farming, combining fish culture with livestock or crops such as fish cum duck or fish cum paddy farming to recycle nutrients efficiently. Then we have Biofloc Technology, BFT, a modern system where microbial flocks convert waste into protein-rich feed, making it a low water exchange and eco-friendly culture technique. Okay. Then we have recirculatory aquaculture system, RAS, a closed loop system where water is filtered and reused, perfect for intensive fish production in limited space. All right. Then we have cage culture. Fish are reared in floating cages in reservoirs or lakes. For example, tilapia, okay, are farmed this way. You should remember the example, tilapia. Okay, cage culture is done for tilapia. Then we have pen culture. Fish are confined in fixed enclosures made in natural water bodies, allowing natural feeding with minimal management. Then we have raceway culture, a system where water flows continuously through long, narrow channels, ideal for fast growing species like trout. Okay. Then we have liming. This is basically adding lime, that is CaCO3, calcium carbonate to pond water. It will help adjust the pH, it will kill the pathogens, and it will also improve the soil fertility. Okay. Then we have aeration. This is basically increasing dissolved oxygen using paddle wheels or blowers to keep fish active and healthy, because they are going to utilize that oxygen. Na? Stocking density, the number of fish per unit area or volume, that is the stocking density. It must be optimized to prevent stress and ensure growth. Then we have carrying capacity, the maximum fish biomass a pond can support without harming water quality or growth rates. Okay. Next we will go to fish seed. Okay, refers to spawn, fry or fingerlings used for stocking. The young stages of fish used for stocking the culture ponds. Then we have fish meal, a high protein feed ingredient prepared from fish waste, vital in formulated feeds. Then we have basics of aquaculture. First one is hatchery, a specialized facility for breeding and seed production, ensuring continuous fish supply for culture systems. Okay. Then brood stock, mature fish maintained for reproduction purposes. For example, Katla broodstock are selected for induced breeding. Then we have induced breeding, okay, artificially stimulating fish to breed using hormones like overprim or overtate, ensuring off-season and mass seed production. You remember the name of this, overprim, and one more is overtide. Okay, so these are the hormones that is used to stimulate the fish to breed. Then we have hypophyseation, the traditional breeding method using extracts from fish pituitary glands to induce spawning. This you all are aware. Then we have nursery pond, used for rearing fry to fingerlings and intermediate growth stage before stocking in grow out ponds. Then we have grow out pond, where fingerlings are raised to marketable size, completing the production cycle. Then we have water quality parameters. Okay, so the ideal condition includes that dissolved oxygen should be 5 to 8 milligram per liter, pH should be between 7 to 8, and ammonia should be less than 0.02 milligram per liter for healthy fish growth. Okay, then next we have FCR, that is feed conversion ratio. It tells how efficiently fish convert feed into flesh. For example, an FCR of 1.2 to 1.5 is to 1 means that, suppose we take 1.2, so it means that 1.2 kg feed produces 1 kg of fish weight, indicating high efficiency. So feeding schedule is, fish are fed daily based on their daily body weight and age. For instance, young fry may get 10% of body weight feed per day, adults around 2 to 3%. Then we have pond fertilization. So adding organic manures like cow dung or inorganic fertilizers promotes plankton, the natural food base. Then we have cage dimension. Commonly cages of 4 into 4 into 4 meters are used in reservoirs, providing sufficient water exchange and space for growth. Then we have harvesting. So the process of removing fish can be partial, selective harvest, or total, complete removal for sale. Okay. Alright, we'll go to the next terminologies, that is life of a fish. Important terminologies. These are going to be how a fish grows from egg to adulthood. Okay. So let's now explore how a fish grows from egg to adulthood. First is egg stage. So the fertilized egg contains yolk reserves for nourishment until hatching. Then we have embryo, the developing fish inside the egg before hatching. Larva, a newly hatched fish carrying a yolk sac that provides nutrition for a few days. Then we have fry. Once the yolk is absorbed, the larva becomes a fry and starts feeding on plankton. Fingerling, a juvenile fish around 5 to 10 centimeter long, ideal for stocking in grow out ponds. Next we have yearling, fish that are 1 year old, usually stronger and ready for market or breeding. Then we have grow out stage, the main production phase where fish are reared until they reach market size. Then is maturity, the stage when fish develop reproductive organs and can spawn. Okay, these are very easy and this is the basics which you have learned in aquaculture. So this will help you understand the aquaculture in total, right? Next we have feeding and growth. Plankton. You might have seen, right? Now only we discussed that the the fry will feed on plankton. Okay. So what is plankton? These are tiny organism, phytoplankton means plants, and there could be zooplankton also, which are like animals which form the natural food base in ponds. Then we have forage fish, small species like anchovies or sardines that serve as food for larger predatory fish. Then we have feed conversion ratio. I have already discussed it. It shows feed efficiency. A lower FCR means better feed utilization. Then we have for supplementary feed. Okay, so additional nutrient rich feed given along with natural food like rice bran and oil cake mixtures. Then we have formulated feed, which means commercially prepared pellets containing a balanced mix of fish meal, oil, vitamins and grains. Then we have feeding rate, the percentage of body weight fish are fed daily adjusted with growth and temperature. Then we have growth rate, measures how fast fish gain weight or length over time, influenced by feed. It could be genetics also, and it could be environment also. So that's a complete and easy breakdown of fisheries and aquaculture terminology, which was clear, concise, and exam ready. Okay. Now on your screen you can see certain practice questions for you to solve. In a recirculatory aquaculture system, the main purpose of biofiltration is to: number 2, which of the following statements correctly differentiates between polyculture and composite fish culture? Okay. Question number 3 is: the process of liming in aquaculture ponds primarily helps in. Number 4, in BFT systems, the carbon to nitrogen ratio of water is maintained high mainly to. Write your answers in the comment section, and thank you for listening to Concept Clarity series. I hope it will prove very beneficial for your upcoming mains examination. Feel free to write your doubts in the comment section if you have any.